Hello everyone, welcome back to our channel. And in today's video, we are going to solve a new LeetCode problem called middle of the linked list. This problem is frequently asked in interviews of tech companies which focus mostly on data structures and algorithm. So solving this problem will test your ability in efficiently solving a problem, and at the same time it will demonstrate your capability with linked lists. So how well you can solve a linked list problem. Okay. So let's go ahead and delve into the problem. So in this problem statement, it is said that you will have to find the middle of the linked list. So here clearly, if you see in the first example, there are 5 nodes, and out of these 5 nodes, 3 is our middle of the linked list. So you will have to return that node. Okay. So in second example, so first example, there were odd number of nodes. So you know that in any odd number, the middle would be just 1. So here in this case, 3, right? So both in the left segment and right segment, we have equal number of elements. So 3 is the middle node. And when the total number of node is even, like in second, there would be 2 middle node. So in this case, it is 3 and 4, right? So in such case, when the total number of node is even, then we'll have to return the second middle node. Okay, so second middle node would be considered a middle node. So these are overall problem statement. Now let's look at the approach to solve this problem. To solve this problem, one straightforward way would be to just count the number of nodes in the linked list and then finally divide that count by 2, and which will be the half of the total number of nodes. And then in the second pass, you iterate till that node and you will find the middle node. Okay. So what I'm trying to say is, in first pass, you keep a pointer and keep on counting till you reach the end. So at this point, when you iterate and then increment your counter, you will find that total number of node is 5. And when you will divide it by 2, then you will get it as 2, or when the ceiling value would be 3. So now you know that you have to iterate till 3 to get the middle node. So that is 1, 2, and 3. Right? So this will be your middle node. So similarly, when the total number of node is even, you will do the same thing. In first pass, you will try to find the total number of node. That will be 6. And then 6 by 2 is 3. You will add 1 to it, and it will become 4. So you know that you will have to, in the second pass, you will have to iterate till 4 node to find a middle node. So that will be till here, right? Because 4 is your middle node. So this approach takes O of n time complexity, but you have to undergo 2 pass. So first pass, in first pass, you will find the total number of node, and in second pass, you will actually find your middle node. Let's look at any other way where you can solve this problem using 1 pass. Another way to solve this problem is by making use of Floyd's hare-and-tortoise algorithm. So Floyd's hare-and-tortoise algorithm says that you will have 2 pointer, slow pointer and fast pointer. Fast pointer will move twice the speed of slow, meaning in each iteration, when slow pointer will move 1 step ahead, then fast pointer will move twice step ahead. Will initially point both in the head of the linked list, and will keep on moving with the logic, that is fast pointer moving twice the speed of slow, and the point when fast pointer reaches the end, by doing this, slow pointer will automatically point to the middle of the linked list. Okay, so let's see how it works. Okay, so initially slow pointer and fast pointer would be pointing to the head of the linked list in this example, and then what will happen is slow pointer will move with 1 step ahead in each iteration, but fast pointer will move with twice step ahead. Okay, so in second iteration, slow pointer will move a point to 3, but fast pointer will move with twice step ahead, and it will point to the last node. So at this point of time, we know that fast pointer have reached the end, that is, it is pointing to the last node. It can't jump twice after this. So we'll stop here and just return the node that is being pointed by the slow pointer, because that would be our middle node. So in this case, it is 3. Okay. And so if we look similarly, if we look in our second example, when the total number of node is even, then you will see that initially slow pointer and fast pointer would be pointing to the head of the linked list. Slow pointer moves with one step in each iteration, but fast pointer with twice step. So in second iteration, it will point here, but fast pointer will point here. In third iteration, it will come here, but fast pointer, when it moves twice, then it will reach the end, that is null. Okay. So now it knows that it can't move forward. So now if we see what slow pointer is pointing to, then it is pointing to our middle of the linked list, that is 4. Now let's try to understand the time complexity. So if you see here, the fast pointer, it moves in such a way that it jumps one node at each iteration. So when the total number of node is 6, then it just needs the n by 2 number of iterations to reach the end. So here you can see it is 1, 2 and 3. So, and in the first example also, if you see, fast pointer will move like this. It will jump from here to here and it will jump from here to here, then it is done. So it is roughly n by 2, or you can say when it is n by 2, then you can say O of n time complexity. So it will just take O of n time complexity and it will find your answer in just one iteration. So just in one pass. So that's how we will solve this problem. Let's look into the coding now. Initially, we'll have a slow pointer and a fast pointer, and both this pointer would be pointing to the head of the linked list. Now what we'll do is we'll run the fast pointer until it reaches the end. So until fast pointer has some value or fast pointer dot next has some value. So in this example, we have seen that when fast pointer is none, then we'll come out of the loop, or and when fast pointer next is null, then we'll come out of the loop. Okay. So until both are there, like fast pointer dot next are there, then we'll run the loop. And what we'll do inside our iteration, we'll move slow pointer with one step ahead, but we'll move fast pointer with twice the speed, that is fp dot next and one more next. Okay. So that's how we will traverse, and at the end we'll know that slow pointer will be pointing to the middle of the linked list. So we can simply return our slow pointer. That's it. Let's run the code. Okay. Now let's submit the code. Cool. So that's how we have successfully solved today's problem, that is middle of the linked list. Solving this problem will really help you showcasing your ability to solve any problem efficiently, and at the same time demonstrate your ability to solve problem with related to linked list. So if you found this video helpful, then give a thumbs up and subscribe to our channel for more coding question and interview preparation. If you have any suggestion or question, then put it in the comment box. Thank you so much. I'll see you in the next video.